Okay, here we go. This is the Unit 2 review. We'll get started. It's a tablet also, so I'm recording what I write, kind of what I say. I'll just put the video on YouTube so I can watch it tonight. I need to review for the test tomorrow. Okay, so this first one, I'm going to go ahead. I want to identify which of the lines is that inequality. So I need a couple points on the line. I know if x is 0, then y would be 160. If y was 0, x would have to be 160 as well. So which of those lines represents that inequality? It's this line right here. So I need to decide which side of that line to shade. Do I shade this side or do I shade the other side? So 0, 0 is not on that line. It's a point down here. If I plug 0, 0 into that inequality, I get 0 is less than or equal to 160 minus 0. That's true. 0 is less than or equal to 160. So I would shade the 0, 0 side of that line. Okay. The next diagonal line I'm working with is this one. So the only other one I've got is that diagonal right there. You'll notice once again 0, 0 is not on that line, so it's a good test point. So 0 greater than or equal to 20 plus 2 times 0. Is that true? Is 0 greater than or equal to 20? No, it's not. So I'm not going to shade the 0, 0 side of that line. I'll shade the other side. Okay. So right now we've got a little bit of an overlap region. Right now the overlap region that we're working with is kind of all this stuff in here. Okay. We're not done. It says y has got to be greater than or equal to 80. So I go to where y is 80. Y is 80 right here. So all the y values above 80, I'll shade above that line. So that'd be above 80, right? We can back up. So the overlap you're going to be looking at when you shade above 80 is the green. So we're working with the green now. We got one more. X is less than or equal to 80. Well, you'll notice for x less than or equal to 80, 80 is all the way out here on x. So if x is less than or equal to 80, that's everything to the left. Well, the region we have already is to the left, so we don't actually need that constraint. It's kind of it's redundant. So our final answer is going to be this region. We can highlight it in. We'll put it in black right here. So that's our final answer in there. Identify the intersection points of the feasible region. So let's clean this up. Okay. So our feasible region. I erase some of this. Okay. So the points I want to know about, I've got this point up here, this point out here. We'll call this point, that first one, we'll call that point 1. And you've got point 2, you've got point 3, point 4. Okay, so point 1 I have as over 0 up 160. Point 2 is the intersection of those two diagonal lines. So those equations are y equals 160 minus x and y equals 20 plus 2x. If I solve this thing algebraically, these guys right now are set up. You could go ahead, let's say you multiply. We want to solve this system, sorry. Oops. Okay. we're going to solve this system of equations right here. So we've got a couple options on how we solve that system. One of them would be you could use substitution. Let's see. Get you to where you have some more room. Okay. This might be a nice one with substitution. You'll notice both of these are equal to y. Like 160 minus x equals y and 20 plus 2x equals y. So that being the case, that means that 160 minus x must be equal to 20 plus 2x. So if I solve for x, okay, minus 20, 140 equals 3x. So x is 140 divided by 3. 3 is a prime number. It doesn't go into 140 because if you add the digits of 140 you get 5, and 5 is not divisible by 3. So x equals 140 over 3. Now you got to figure out what y is. You can plug that into any of your equations. I'm going to go with the top one. Y equals 160 minus 140 over 3. I'm going to solve for y. I don't like the fraction, so I'm going to multiply everything by 3. So 3 times y will be 3y. 3 times 160, 300, 480. Yeah, 480. And 140 over 3 times 3 is just 140. 480 minus 140 is 340. And divide both sides by 3 and you get y equals 340 over 3. 340 over 3 does not reduce either. So that intersection point, you got the x, 140 thirds, and the y, 340 thirds. Oops. So that second point we had was 140 thirds, 340 thirds. Okay. The third point, that crossed that lattice point, that was just the coordinate. X is 30, y is 80. And the fourth point was x is 0, y is 80. Okay. Evaluate the objective function at each of those points. So to get the value of the objective function, you'll multiply 22 by the x and then add that to 111 times the y. So for the first point, it would be 22 times the x of 0 plus 111 times the y of 160. So 111 times 160 is 17760. Yeah. How you doing? Question? Let me pause this real quick. Okay, so we're going to keep going. That second point, 22 times 140 thirds plus 111 times 340 thirds. I've got my calculator here, so we'll just plug that in. 22 times 140 thirds plus 111 times 340 thirds. So if you want it as a fraction, it's 40820 over 3. And you're fine doing that on a calculator, which is approximately 13606.7. So we got a few answers right now. Got that one. We got two more objective. 2 more points to plug into the objective function. So point 3, 30 and 80. So you go 22 times 30 plus 111 times 80, and you're going to get 9540. 9540. Fourth point, 0 and 80. 22 times 0 plus 111 times 80. 111 times 80 gives you 8880. So if your goal would have been, they didn't ask for it specifically, to maximize the objective function, the point that would have maximized it would have been 0, 160. So that was your 17,760. They just wanted you to evaluate the objective function. Okay. Okay, another shading. Let me do this guy. Okay. So I got a couple lines here. I need to graph them. If x is 0, y would be 250. If y was 0, x would have to be 10. So that is this line right here. 0, 0 is not on that line. 0, 0 makes that inequality true. So you would shade the 0, 0 side of that line. Okay, the other diagonal line is obviously this equation right here. 0, 0 is not on that line. 0, 0 makes that inequality, let's see, 0 less than or equal to 115 thirds times 0 plus 60. Is 0 less than or equal to 60? Yes, it is. So you would shade the 0, 0 side of that line as well. Okay, and then it says y has got to be less than or equal to 75. So I'll find where y equals 75. So right here is where y is 75. So it says we want to be greater than or equal to 75. So above that. So our feasible region, so if we're going to shade above this, our final feasible region that meets all of those requirements will be this green region in here. Okay. So we got to identify the intersection points. So you got this guy here, and this guy here. So let's take the two diagonal lines. Let's say we're going to go for this one first. Look at where those two diagonal lines meet. So you got 25x plus y equals 250. And the next one is y equals 115 over 3 times x plus 60. So let's go figure out where those guys intersect. Okay, you know what? I'm gonna go ahead and clean up this second equation real quick. Multiply everything by 3. 3y equals 115x plus 180. And I'm gonna go ahead and use elimination. So let's see. I'll get the x's and y's on the same side. So this guy is 3y minus 115x equals 180. So if I'm looking at combining these two equations, if I just add them up right now, I'm not going to get any variables to drop out. So if I multiply, I'm going to multiply this guy up here by negative 3. So it would be negative, I'm going to rearrange it a little, negative 3y minus 75x equals negative 750. And the other one was 3y minus 115x equals 180. Now I can add them up, the y's will drop out. This would be negative 190x equals, let's see, 750 minus 180, 650 minus 80, 600 minus 30, 570? 570. And then divide both sides by negative 180. Oh, that'd be negative 570. So 570 over 190 is going to be 57 over 19. And that is 3. So if we go back up, where those two diagonal lines intersected, x is 3. Oops. Alright, so we're a little bit past it. Computer's jumping around a little. Okay. Yep, so x is 3. And I think that one was on a... You would have seen that on the lattice point. So x is 3. So in either of those diagonal lines, if you plug x in for 3, you get 175 for y. So we know we got when x is 3, y is 175. The other ones are probably going to be more interesting. You need to know where each of those diagonal lines matches up with the y equals 75. So if y is 75, we can plug that in for each of those lines. So you got the 25x plus 75 equals 250. Solve that for x. You get 25x equals 250 minus 75 is 175. 175 divided by 25 is 7. So we've got our other point. This one here is 7 comma 75. Okay, the other one was, how you doing? The other one is 75 equals 115 over 3 times x plus 60. Multiply everything by 3. So 3 times 75 is 225. 225 equals 115x plus 180. Subtract 180 from both sides. 45. Yep, 45 equals 115x. Divide both sides by 115. And you get 9 over 23. So x is 9 over 23. I gotta plug that back in to find y real quick. Oh, but we already know where those two lines intersect. Y is 75. Okay, so then you evaluate your objective function. We've done that. You take each of your x's, plug them in for the x, and then their corresponding y would get plugged in for the y, and you'd figure out the total there. Which point of intersection gives the maximum value for the objective function 2x plus 12y? So this is just x, y, x, y, x, y, x, y. So for this first one, 2 times the x of 0 plus 12 times the y of 16 is going to get you, let's see, 12 times 16, 192. Okay, the second point, 0, 0, is going to get you a total of 0. The third point would be 2 times the x of 6 plus 12 times the y of 12. So 144 plus 12, 156. Okay, that's this point's total. Probably shouldn't circle these because that'll be your answer, whatever you circle. Okay, then the last point, 12 times the x, sorry, 2 times the x of 12 plus 12 times the y, which is 0. That's only 24. So the one that maximizes the objective function, well, the greatest output we saw was 192, and that was generated by option A. Okay, moving on, getting closer. F4 is the same style. Which point of intersection gives a maximum value of the objective function? Oops. Computer's freaking out a little. Okay. All right, now let's go back. Okay. So we don't need the graph here. I mean, they give us the points to check. So we've done this style of problem before. Here's the x, here's the y, here's the x, here's the y. Plug it in, see which of those maximizes this guy here. Okay, so the answer to number 4, looking at my key here, is C with a maximum of, I think that generates 288. Okay, then we move on to 5. 5 is a little tough to see, so I'll try to more clearly identify the feasible region. The feasible region we're looking at in 5 is this guy in here. That's our feasible region. So we'll get started. So let's say this first one, y is less than or equal to negative 2x plus 12. I need to figure out which line that is. So I know when x is 0, y is 12. When y is 0, x would need to be 6. So this line right here we know that our feasible region is on the 0, 0 side of that line. So 0, 0 needs to make these inequalities true. So does it make all of those true? And I think that it does. They're all the same, right? Yeah. If you plug 0, 0, I mean, every one of these three is the same. And when you plug 0, 0 into those, you get it. It's true. So that line didn't really help. Let's go with the next one. Okay, so when x is 0, y would be 6. When y is 0, x would be, let's see, 180 by 12 would be 15. So that is this line right here. 0, 0 is not on that line, so it's a good test point. So it looks like we wanted to shade the 0, 0 side. So does 0, 0, which of these inequalities does 0, 0 satisfy? And it does satisfy the first one. It does not satisfy the second one. It does satisfy the third one. So it can't be option B. Okay, so this guy now, it's the last diagonal line. It's this one here. 0, 0 is not on the line, and we shaded the 0, 0 side of it. So which one of these two does 0, 0 satisfy? Because we shaded the 0, 0 side. It does not. Let's see, 0, 0. It satisfies the first one. Oh, I gotta pay attention here. Those are different. Those are different equations. So like this equation, the intercepts for that equation are when x is 0, y is negative 7.5, and when y is 0, x is 7.5. This guy, when x is 0, y is 7.5. When y is 0, x is 7.5. So that purple line is generated with these two. So the answer to 5 is C. Okay, let me go to 6. Okay, so another determine which one is the feasible region. So you got a bunch of things to consider. I noticed that guy and that guy are the same. Well, except for the way the inequality goes, and that those two are the same. So let's take those purple ones real quick. Okay, when x is 0, y is 15. When y is 0, x is 15. So that line is this one right here. That's the line we're looking at. And we did not shade the 0, 0 side of that line. So, of the two purples, does 0, 0 make that inequality true or false? We did not shade the 0, 0 side. So, we're looking for the purple that 0, 0 makes false. 0, 0 makes this one false. And it makes this one true. So we did not shade the 0, 0 side of that line, so it's not this one. So now the two blues. Let's see if that line is even on the graph. It says when x is 0, y would be 7.5. When y is 0, x would be 7.5. That's not even an... and the blues are actually different. For this one, when x is 0, y is 8. When y is 0, x is 8. Neither of those guys are actually even on our graph. We don't have graphs of those lines. So our answer is A.